So let's take a look at what infinite and no solution type problems would look like. So here's our problem that we're going to work with today. This is 3x minus 13 equals 7 times x plus 2 minus 4 times x minus 7. So in order to do this problem, this is again another multi-step equation with variables on both sides. So just like we did before, we're going to distribute this 7 or multiply the 7 in. So this would become 7x plus 14. This is I'm treating this minus 4 as a plus negative, so I'm multiplying through a negative 4 into both of those. So this would become minus 4x plus 28. And I still had the original 3x minus 13 on my left-hand side. So at this point, just like I have in the previous two videos, I'm going to combine like terms. This would then give me 3x. I'm combining the 14 and the 28, and that's going to give me 42. And this is equal to 3x minus 13. So just like we did on multi-step equations, what we want to do is we want to isolate that variable. So in order to isolate the variable, and when I see them on both sides, I need to move it to the other. So I'm going to move this 3x by doing the opposite operation over to the other side. This will cancel. But what I notice in this case is it cancels over here also. So what I'm left with is negative 13 equals 42, which is not a true statement. That is not true. And when you end up solving these and you get a not true statement, this would be considered a no solution. So I want to write that down. Rule number 1 or situation number 1. If it is not true, at the end of your problem, if it is not true, your answer will then be listed as no solution. Now here's another problem. If I gave you as an example 3 times 2x plus 2 minus 3x equals 6 plus 3x, and I asked you to solve this problem, I would do the exact same thing. I would distribute in. So 3 times 2x is 6x. 3 times 2 is 6 minus 3x, because that was in the original problem, equals 6 plus 3x. When I go to combine like terms, this 6x and this minus 3x are going to combine to become 3x plus 6. And over here, I have a 6 plus 3x. So just like I've done in the past, I want to move my x's over to the other side. So I'm going to do the opposite operation, minus 3x. And what I notice is that, again, it cancels out on both sides. But on this time, if you look at what's left over, it's a true statement. 6 equals 6. That's true. 6 does equal 6. So this is a true statement. And when we have a true statement, we would say that this is infinitely many solutions. So if we go back up to our rules or our list of rules, rule number 2 would be if it is true. And other examples of true statements could be 10 equals 10, negative 4 equals negative 4, 3x equals 3x. If it is the exact same thing on the left-hand side as it is on the right-hand side, exact same thing, we would call this infinitely many solutions.